my name is Gil Hildebrand. I'm the chief engineer of Squidoo.com, and I'm here to talk to you today about how you can leverage Amazon Web Services to supplement your existing server architecture. So before I get started, can I just see a quick show of hands to see how many people are using Amazon? Oh wow, you guys should be up here teaching me. So as I mentioned, I'm one of the co-founders of Squidoo.com. We started the site in 2005. At the time, there weren't many sophisticated ORMs or frameworks out there. Rails was really just getting started, and certainly no one was talking about cloud computing. So we wound up developing a custom PHP framework with a very, very traditional backend for physical servers, 2 web servers, 1 database server, and 1 staging server. And at that time, we relied heavily on our managed hosting provider for pretty much all of our system administration work. Whoops. Today we have a little bit over 22 million page views a month. All that's hosted on 8 physical servers, 4 web servers, 3 database servers, and 1 database, and 1 staging server. And our current hardware leaves us plenty of room for growth. We probably are at about 60% capacity. We only have 6 employees in the company, only 3 people on the technical staff, no full-time server admin, and very little interaction with our hosting provider. Now the way we're able to do that is by leveraging the tools that Amazon provides. They provide essentially a framework for solving scaling problems. What it allows you to do is break up large generalized components, let's say a single server that would be your web and database server, into smaller specialized components, which are then easier to optimize. The way I look at it, Amazon has a lot more experience with these types of problems than I do. I can remember being on the net in 97 or 98 and seeing banner ads for Amazon and not having any idea what it was. So I put a little bit more faith in their abilities than mine. And not to say that we don't have safeguards, but the fact that I can outsource most of the pain of worrying about high availability is something that's absolutely priceless to me, especially since I don't want to be on call 24 hours a day. And it's not an all or nothing approach, right? You don't have to all of a sudden decide to make the leap into cloud computing, dive headfirst by setting up Amazon EC2 instances with auto scaling and load balancing and round-robin DNS. You really don't have to get started that way. You can set up an SQS queue, or you can store some of your user-generated content on S3 and still maintain a sort of traditional infrastructure, and that allows you to just experiment with the technology and become more comfortable with it. So I only have 3 recipes to share with you today. I tried to fit in more, but I just didn't have the time. The first is quick and easy database backups to S3. So there are a lot of different solutions being offered at the conference for database backups, but this one is so simple that I couldn't resist. The second one is storing your static content on CloudFront, which is Amazon CDN. And the third one is scaling traffic analytics with SimpleDB, which is very similar to CouchDB that Jan just presented. So Amazon provides a number of tools. They have command line tools for basically all of their products. They also have a management console, which is EC2 only at the moment, but they're extending to their other services. There are Firefox add-ons. There's my personal favorite, RightScale.com, which is basically a full-featured GUI interface for pretty much everything Amazon. And finally, some of the examples I'm going to show today use the Tarzan wrapper library for PHP. So I'm not actually going to show you how to create things with Amazon. I'm not going to show you how to use the tools because there's plenty of documentation for that. The first recipe for database backups. Initially, when we created the site, we relied on MySQL dump and gzip. That works great up to a point. Our managed hosting provider essentially just stored backups of all of our hard drives and made tapes and kept those off-site. The problem with that is they tend to charge, from my experience at least, between $1 and $3 per gigabyte per month. And the restores always require some sort of tech support. And that can take hours, especially if the backup is off-site, and that's not something that you really want to wait around for. So we began experimenting with S3, and by definition, the files are stored off-site. The pricing peaks at 15 cents per gigabyte stored, and since this is for backups, the bandwidth costs are minimal since you're not really using it that often. And of course, there's no tech support call required if you need to restore anything. You can download the files at the speed of light. So there are two problems though. The first is that S3 has a storage limit of 5 gigabytes per file. That means you can't just take a single tar archive of a large database and store it in a single file. The second problem is that MySQL dump is slow and pretty much boring. The solution we chose to use was one of the motkit tools from Percona, MK Parallel Dump. It dumps one table per file, which sort of helps to get around that 5 gigabyte limit. And if the files are still greater than 5 gigabytes, you can use the chunk size flag to make those files smaller. And it is faster on many data sets because essentially what it's doing is executing MySQL dump in parallel. The first flag that we use is the tab flag. That selects into out file as opposed to MySQL dump. It's generally a little bit faster, especially on the local host, and it makes it possible to restore views and triggers and things like that. We also use the stop slave flag to stop the slave while taking a backup. This essentially ensures that we get a consistent read. But just a quick warning, what I'm going to show you is something that's intended to be run only on a slave database server. It needs to be a server that you can tolerate a replication break on while the backup's being taken. One option, this is what we do, is just to keep a slave running on a spare server, and that allows us to use it solely for taking backups. So you'll need an AWS account, obviously, with your authentication information. You'll need to create an S3 bucket called MyS3 Backup. You'll need a tool called S3 Sync. This is a Ruby tool which works just like rsync on the command line. And finally, you'll need motkit. So here's a dead simple database backup script, just a simple shell script. So we have the first line, which just creates a backup directory. Then we'll call MK Parallel Dump with our flags. This will create the backup files, and then we'll just simply sync those files to S3 and do some cleanup. A few ways you can improve this. If you have the disk space, it's always good to keep the backup files locally as well, at least for a short period of time. You can also build a completely independent tool to check S3 every day just to make sure your backup files are actually being stored and that there's no problems. And you always want to have a restore script ready to go, right? Because you don't want to have to do that when you're in the middle of some kind of major meltdown. So here's a simple restore script I use. Hopefully you guys can see it. This script will allow you to restore specific tables. And so the first thing we're going to do is create a temp directory to hold the data. Then we're going to loop through all the tables, use S3 command, which comes with S3 sync, and that's just going to download all the tables from S3 that we need, and then we'll restore those specific tables to this local MySQL server. So really simple. The second recipe is effortless static content, and of course by that I mean JavaScript and CSS and images. It turns out Apache is just terrible for hosting static content, and besides that, it's better to let your application servers do what they're really born to do, which is serve dynamic content, not simple things like text files. And static content is bandwidth intensive, so you always want fast downloads, and you want to cache as aggressively as possible. So that's when we began experimenting with CloudFront. Of course, it's a CDN that competes with Akamai and Limelight. If you've ever dealt with either one of those companies, you know that it's pretty annoying to have to deal with salesmen and try to estimate how much bandwidth you're going to use, which is pretty much impossible, and then deal with proposals and things like that. So the great thing about CloudFront is you just set it up and get started, and you just pay for what you use. In the US and Europe, bandwidth pricing peaked at 17 cents per gigabyte. It's a little bit more expensive than that in Asia. And in our specific application, there's a per HTTP request cost, and that winds up being about 50% of our bandwidth costs. Again, that's just our specific application. So how expensive is it? In general, it's more expensive than hosting it yourself. At Squidoo, it's about 30% more expensive than if you're going to host that content on small load-balanced EC2 instances running Lighty, which is a pretty lightweight way to do it. But the fact that I don't have any servers to maintain anymore is priceless, and I wouldn't trade that for the world. And of course, research from Google shows that that faster load times definitely equals more revenue. We haven't really seen that in our application yet, but we're still tweaking some things. So that's the argument for CloudFront. And of course, you want to have aggressive caching. In a perfect world, your static content will stay cached on the client forever. That means faster load times for the client and lower bandwidth costs for you. But to accomplish this with CloudFront, the file names have to be unique. Otherwise, clients with a local cache won't always download the latest copy of a file. And it's also important because CloudFront's edge locations throughout the world will cache your data too. So there's 5 steps to creating a CloudFront distribution. The first is to create an S3 bucket. This is going to store all of your static content. The second is to tell Amazon that you want to use CloudFront as a CDN for that S3 bucket. The third is to update your code to point to the CloudFront domain that Amazon gives you, as opposed to using your local domain. Fourth step is to add versioning support, which I'll show you an example of in just a second. And finally, you just deploy your version files to S3. So I mentioned version support. Really, in order for this to work and to make sure that no one is ever seeing an old version of one of your files, you want to have a version number in your files. And there's plenty of ways to do that, but here's the way that we accomplished it. Maybe it'll give you some ideas. First step is we created basically a configuration log. This keeps track of all of our static files and which version number they are. Anytime one of our developers changes one of these static files, they'll just go into this configuration file and increment that number by 1. You can integrate this with Subversion or your other source control programs, but it's a bit trickier because you don't want to increment those version numbers with every release unless the file was actually changed. The second step is to update your code. This first line here is just something I would have in my controller. Normally, it's just going to say what style sheets I want to use on the page. Then I'm going to require that configuration file that we just discussed. And I'll loop through all the style sheets. And for each style sheet, I'll check to see if it's a version style sheet. And if so, I'll change the name of the style sheet to use the version number. And then I'll, of course, construct the link tag, which puts the style sheet on the page. And you would want to do the same step for all of your JavaScript and images as well. The next step is you need to modify your deployment script, which I hope you have one, to use CloudFront to push your files to S3. So we use Capistrano. Even though it's a Rails project, it works really well for us. And here's the Capistrano way to do it. Whoops. That is, there we go. So here we're just going to export the latest distribution to a temporary directory, and then we're going to call a PHP script, which will deploy those changes to S3. Here's that PHP script. It's going to accept the temporary directory as an argument. Then it's going to open up that static content configuration file, and it'll loop through all the style sheets and copy the style sheet, essentially rename it to the version style sheet. And then we'll push those files to an S3 bucket using S3 sync. We want to make it publicly readable, and notice the really large expiration for the cache. So the final recipe that I wanted to show you guys is something that's really, really cool. At Squidoo, we have in-house analytics. We debated using something like Google Analytics, but ultimately we didn't want our users to have to click away to another site in order to see their traffic for their pages. In addition to that, we have ranking algorithms, and we wanted to have those traffic numbers in-house so that we could incorporate it with our ranking algorithms. If it weren't for those two things, we probably wouldn't have bothered with traffic analytics at all. So in our application, because each page on our site is totally unique and is a standalone website, we define a unique as an IP address that has not been to this specific days in the past, to this specific page in the past 7 days. That means that each page view requires a lookup to determine whether the page view is unique or repeat. And it's impossible to scale many simultaneous reads and writes on such a small amount of data. And as it turned out, unfortunately, MySQL just couldn't keep up with the load. Really, relational databases aren't designed for this sort of high concurrency environment. We were able to get by for a while by using MySQL's insert delete that helped us get around some of the locking issues. But ultimately, the locking issues became too much when we wanted to just purge some of the old data that we didn't care about anymore. And of course, you can create summary tables so that you can say, here's all the traffic that went to this page in the past day. But that didn't work for us because we also need to be able to show things like refers. So we still needed the granular data. That's when I began experimenting with SimpleDB. The great thing about it is it's non-blocking, fast querying. It's schemaless with auto-indexing, so you never have to worry about running an alter table and having to take down your application in the process. And it's suitable for high concurrency environments. There are a few things to be concerned about, though. The first is that it's really difficult to estimate costs for using the application, but there is a free tier so that you can get started and sort of experiment with it before you commit. It uses eventual consistency, meaning that if you do a write, it may take a couple of seconds for the write to propagate across the system. So if you're in a particular application where you need to do writes and then reads on the data immediately after, it may not work so well. Another point is that you can't have null values, and the data must be URL encoded, especially if you're trying to store a URL. They call it simple for a reason. There are a whole lot of limits to what it can do. First of all, there's a limit of 10 gigabytes per domain. A domain is basically like a database. There's a limit of 1K for attributes, which are like columns. And there's a limit of 5 seconds for each query that's run, although Amazon will return a next token, which will allow you to essentially page through the results. So here are a few definitions. As I said, domain is basically like a database. An item is like a row. An attribute is like a column. And a value is like a single cell of data, with the exception that an attribute can have multiple values. So in a normal relational database, if you wanted to have multiple colors assigned to a single widget, you would create a colors table and have multiple rows that link back to that one widget. In SimpleDB, that's not necessary because you can have one attribute, one widget, be both blue and red at the same time. So using SimpleDB, here's a query that I've constructed to determine the uniqueness of a page view. These things in brackets are called predicates, and predicates essentially evaluate one particular attribute at a time, and you can grab results using either the intersection or the union of different predicates. And also, everything in SimpleDB is essentially a string. So when I'm using date saved here, I'm actually storing this as a Unix timestamp as opposed to date time format. Another thing about SimpleDB is that you have to specify item names for each row that's stored. It's like a primary key, except that there's no index association with it. But you do need to use that throughout the application, so it's important to know. In this particular case, I'm just using the IP address, the page ID, and Unix timestamp. So here's how I record a page view. At the top, we have that uniqueness query to determine whether or not this is a unique page view. We're going to query SimpleDB, but we really only want to know if there's a single visit to this particular page in the past week. So I'm only going to ask for one result. I'm going to assume that the page view is not unique unless I do receive an item name back from SimpleDB, then it is a unique page view. So now we're getting ready to insert a new row. As I mentioned, you have to essentially give a key to every single row that you insert, and it's as simple as that. So there's a couple ways you can make this better. You can use memcache to cache the uniqueness so that you don't have to look it up every single time. That helps a whole lot. You can also, for large data sets or extremely high concurrency, if you happen to be throttled by Amazon, or if your data set is larger than 10 gigabytes, you can create multiple domains and essentially use them in parallel. You can also use a hash algorithm to store items in a consistent domain, and that allows you to essentially predict which domain a piece of data is going to be on. And finally, if you're going to use multiple domains, it's always a good idea to experiment with curl multi to request data in parallel as opposed to serially. Here's one more example with SimpleDB. This is going to create a summary table, essentially recording the traffic for each page on the, or totaling the traffic for each page on the site for a single day. So I'm going to look for all visits to the site where the date saved is yesterday and where the visits are unique. You'll notice I have a next token defined here. We'll get to that in just a second. We're going to create an infinite loop here that will eventually break, but we want to know basically the page ID for every visit to the site yesterday. And we'll pass a next token, although it's null at the beginning. Through subsequent trips through the loop, the next token will be defined with the page results that Amazon provides. Amazon will only give you up to 255 rows at a time when you query it, so you have to keep iterating through this loop to grab all the data that you need. So we'll run the query, and then for each visit, we'll grab the page ID, increment a counter, check if there's a next token, and if so, we'll continue paging through the results. If not, we'll break out of the loop, and then just save the data into MySQL. So I didn't include an example using EC2, mainly for time constraints, but also because a lot of the problems that people tend to talk, time constraints, right? I'm almost done. Also, people tend to solve these types of problems with EC2 on their own at the moment, but Amazon is actually working on ways to solve them internally so you won't have to worry about it. Amazon has some other goodies that are definitely cool to check out. And here are two general tips. You should expect failure in retry fail queries. And you also want to make sure that your system time is always correct, or your API calls will fail. So that's it.